Okay, so in this video, I'm actually going to show you how to use Excel, a spreadsheet program. I will also show you how to use Sheets in a different one because it is slightly different. This is Excel. If you have, I think this is the 2013 version. If you have the 2010, it's slightly different. If you have it for a Mac, it's slightly different. But for a PC with 2013, this is how it works. And a spreadsheet program is really, really useful. It can do a lot of calculations for you very, very quickly, which is what makes it awesome. And it can do graphing also very, very quickly. So, and analysis of the graph. So what I'm going to do is show you how to use it. If you already know how to use it, you can skip the video. No worries. First things first, this little square there is referred to as a cell. C-E-L-L. It is referred to as cell A1 because it's in the column A and row 1. And that's how you refer to them. So cell A1, and what you're going to talk about is putting in the data, or labeling the data, or populating the cells. And we'll talk about how to do each of those. Right now you notice I've got some numbers in there. This is just my data for the water. And so what I'm going to do is I'm going to label each one of these cells. So when it says in your instructions to label cell B1, you're going to call it mass of water alone, and you should put a G afterwards because it's in grams. Now you might notice, wait a minute, that like extends out. That's not very pretty looking. Okay, and so if you want it to look better, there's a couple ways you can do it. One way you can do it is go over here between the B column and then take that line, I have a stylus, it's not as good as a mouse, and expand it out. Now that wastes a whole lot of paper. It doesn't look particularly nice. So what I would prefer to do is make the columns about the width of the numbers, and then under home, you're going to wrap text. And what that does is it puts the words fit into that shape. Okay? You don't have to make the shape quite so big. In cell A1, you're going to type in volume of water. This would be in milliliters. Enter. And again, it did the same thing. So instead of making the column enormous, I'm going to wrap the text. And if I want to expand it, I can do that. I mean, if this is kind of squished, I can expand it out a little bit, make it a little bit better looking, you know, maybe try and get that on 2 lines. Okay, in column C1, you're going to type in, come on, oh, I got the keys in the wrong place, density of water. The units would be grams per milliliter. Milliliter. What's it doing? Milliliter. There we go. Okay. And again, it's kind of too big for me, so I'm going to just take it and expand that out a little bit. Okay, so then you're going to type in your data. Okay, over here in column F, you're going to do the same kind of thing. I'm not going to show you that one, but you follow the instructions, repeat the same process. Column F1, column E1, column G1. Okay, do it the exact same way. And set it up, put in all your data that you collected during the lab. Okay, now at this point, you're going to let Excel do the calculations for you. Okay, you don't type in the data. This column right here, I don't want you doing your calculator on this one. I'm going to show you how Excel does it for you. Excel is awesome. Okay, so what I want you to do is in cell C2, once you've got your data typed in, I'm going to have you go ahead and type in equals. And that's very important. You have to tell Excel what to do. Okay, Excel is not as smart as you are. You know what Excel needs to do, but it doesn't. And so you need to type it in and tell it what to do, and that's what the equals is all about. And then in order to find density, you're going to take the mass, so in this case that would be cell B2. You're going to divide by the volume, in this case that would be cell A2, and then you hit enter. And now you might think, well, no, God, it's a lot easier on my calculator to do that. And you would be right. But here's where the cool thing about Excel comes in. If you go back and you click on cell C2, the bottom right corner, you might see that little green square. What you're going to do is take that green square and drag it all the way down. Oops, don't move it. I have a stylus. It doesn't work as well. Drag it all the way down the bottom, and it calculates the densities for you for every cell. And if you click on this one, you might see it says B4 divided by A4. That would be the mass in B4 divided by the volume in A4. And that's what it does. That's what makes Excel awesome, is that it can do a ton of calculations really, really quick. Okay, so that's one thing you're going to do. Now I want to talk a little bit about Sig Figs before we move on. Okay, first of all, when you measured this, you used a graduated cylinder. Graduated cylinders are actually a lot more accurate than most people give them credit for. They have at least one decimal after the decimal point. And so what I'm going to do is I'm going to highlight column A. So the way I do that is I click on column A, just like clicking on B, column A. And I want to tell Excel, you know what? 10 is not good enough. That's only one sig fig. That kind of sucks in terms of sig figs. So what I'm going to do is go over here, and it might have said general in the beginning, but now I'm going to change it to number. And right here in those two little spots, if you notice, that changes how many decimal places you have. I can decrease the number of decimals, or I can increase them as many as I want. Okay? Now, if you look at your data table, you should have one number after the decimal point, giving every single one of those volumes 3 sig figs, except for the last one, which actually has 4. Okay? The other thing I want you to notice, on the mass of water, when you measured it on the digital scales, it should have given you 2 decimal points. Now, again, Excel is not as smart as you are, and it might not have put some extra zeros where there should be zeros. So what we're going to do is, again, go to Home, go under General, turn it into a number, and if it doesn't give you 2 decimal places, make it give you 2 decimal places. All right? Now let's talk about the density. To calculate the density, you took the mass and you divided by the volume. Now if you look, in the first case you have 3 numbers divided by 3 numbers, 3 sig figs. The second case you had 4 sig figs divided by 3 sig figs, so you should have 3. So all of these should have a maximum of 3 sig figs. They actually should have exactly 3 sig figs, with the exception of the very last number, because this one here was 4 sig figs divided by 4 sig figs. So what we're going to do is we're going to tell Excel, give me one more decimal on that one. There we go. Okay, so now it has 4 sig figs. Remember, the zeros on the left don't count. All right, so that's that. All right, so you would do the same kind of thing with the clay. I'm not going to do the clay, and I'm going to talk about how to make a graph. Okay, here's how you're going to do the graph. You're going to take your mouse. In my case, I have a stylus. You're going to highlight those 2 columns. Okay, the mass and the volume, and you're going to plot them in a graph. And the kind of graph you're going to do is called a scatter plot. So under Insert, you go to this little dotted thing, Scatter Plot. There it is. Lovely. I don't like that thing. All right. Looks like a nice straight line. Now you want to check and make sure that things are correct, that your x-axis represents the volume and your y-axis represents the mass. And the reason why that's important is because mass divided by volume, y over x, is slope. And it's also density. So if you click on that point, it says 60 and 59.25. So 60 is my x value, that's volume, and the 59.25 is my mass. And it doesn't matter which one you pick as long as you look back at your data and see that your x values are the volume and your y values are the mass. All right, so now you've got this plotted. First of all, we're going to change the chart title. We're going to call it Density of Water in grams per milliliter. Okay, got to give it a title. You also have to label the axes. Okay, and so under this, it should be under Format, I believe in Excel. Nope, I lied. Design, I think. Add chart element. You want to add axis titles. The primary horizontal, remember this was volume of water. Volume, come on. Volume of water, milliliters. All right. And then you want to click on it again, and you want to go to Format, nope, Design again, Add Chart Element. This time you're going to do vertical one. You're going to call this Mass of, I'll stop it. Click on the thing. It's not fun having a stylus, I gotta tell you. Mass of water in grams. All right, so now I've labeled all my axes. I've given it a chart title. I also need to give what's called a best fit line, and this is one of the very cool things that Excel can do, and Sheets. What you're going to do is you're going to go over to one of these data points and you're going to right click on it, and then it's going to say Add Trend Line. Now it's in different places on different programs, but add trend line, and then you have options. All right, it obviously looks like a line. It's a pretty good line, actually. We want to just automatically come up with it, but the big thing we want to do is we want to include the equation for that line. because that line represents the density of water in our data. So we're going to display the equation and display the r² value. Okay, so what you see here is this equation. I'm going to slide it over a little bit. Okay, that equation is referring to this line. Okay, the r² value, what that tells you is how good your data is, how close it is to 1 or -1. Tells you it's how close to being a perfect set of data. Well, look at mine, 0.9998. Now, granted, I made those numbers up. Okay, yours may or may not be that good. It's okay, but it just tells you how good your data is, how close it is to being a perfect line. Okay, then I want to talk a little bit about what this number represents right here. That 0.9917. If you think back to math class, that is referring to the slope, right? Y equals mx plus b. Well, in this case, slope, rise over run, is representing mass over volume. That slope that I just highlighted, the 0.9917, represents the density of water. And this, the 0.212, represents the y-intercept. It should be, if it was perfect data, 0. Because if something has 0 volume, it has 0 mass. Okay, so it should be 0. It's not 0. It's okay. But the idea is to recognize how the mathematics apply to the science. First of all, slope represents the density, the 0.212 represents the y-intercept, and the r² value tells you how close you are to having a perfect line. Okay, so that's what you're going to do to make a graph. You're going to do that for the clay as well. It's not going to be nearly as nice in the clay. It's going to be all over the place. But the point is to understand how to use Excel. Now I will go over this again in class, and I'm also going to make a video for how to do this using sheets.